Consider a network as shown. Thevenin's theorem states that this network may be reduced to a simplified two-terminal circuit consisting of a single voltage source in a series with a single resistor. Now, let's go on the steps in Thevenizing a circuit. First, disconnect R sub L to find the voltage across A and B. Since terminal AB is parallel to R sub 2, the voltage across AB is equal to the voltage across the 6 ohm resistor. The equivalent resistance of the circuit is 9 ohms. Therefore, the current passing through each resistor is equal to 4 amperes. By Ohm's law, the voltage across the 6 ohm resistor is equal to 6 ohms times 4 amperes equals 24 volts. Therefore, the Thevenin voltage is equal to 24 volts. Next, make a short across the terminal where the voltage source is. Imagine a voltage source with a certain voltage across terminals A and B. Find the equivalent resistance with respect to terminals A and B. In this case, the two resistors are parallel with each other. Therefore, their equivalent resistance is 2 ohms. This is now our Thevenin's resistance. The next step is to construct a Thevenin equivalent circuit. To make the Thevenin equivalent circuit, connect the Thevenin resistance and the Thevenin voltage in series with one another. And the last step, reconnect R sub L to the Thevenin equivalent circuit and solve the circuit. Now, let's try to find the Thevenin resistance and Thevenin voltage from the given circuit below. First, disconnect R sub L to the voltage across terminal AB. Now, the voltage produced by the 28-volt voltage source on the 4 ohm resistor is 22.4 volts. The voltage produced by the 7-volt battery on the 4 ohm resistor is 5.6 volts. Therefore, the voltage across V sub 1 is 22.4 volts minus 5.6 volts, which now equates to 16.8 volts. The voltage produced now by the 28-volt voltage source on the 1 ohm resistor is 5.6 volts, and the voltage produced by the 7-volt battery on the 1 ohm resistor is 1.4 volts. Therefore, the voltage across V sub 2 is 5.6 volts minus 1.4 volts equals, since the 28-volt voltage source is opposed by 16.8 volts, we have to subtract 28 volts minus 16.8 volts is equal to 11.2 volts. To check our answers, the 7-volt battery is not opposed by the 4.2 volts. Therefore, 7 volts plus 4.2 volts is equal to 11.2 volts, which is indeed the Thevenin voltage. Next is to find the Thevenin resistance. First, make a short circuit across the voltage sources. Again, imagine a voltage source at terminal AB. Then solve the circuit with respect to the voltage sources. Since the 4 ohm resistor and the 1 ohm resistor are connected in parallel, the equivalent resistance is 0.8 ohms, which is also now our Thevenin resistance. Now, the Thevenin equivalent circuit has a Thevenin voltage of 11.2 volts, which is in series with a 0.8 ohm resistor. In order to solve the circuit, we must reconnect R sub L and solve for the unknown quantity.